The Sun is an incredibly large celestial body, but you may have heard that there is a giant star that is bigger than the Sun by almost the same margin. Hello everyone. But among these giant stars, there is one that is of an extraordinary size. Welcome to our channel everyone. Today I'd like to introduce you to one of them. It is probably the largest star known to mankind. Let's get started. The largest of the largest. The star I am about to introduce is named Stephenson 218. This star is located in the constellation Mains as the Scuti, which had previously reigned as the #1 star. Scuti was once considered the largest star, but Stephenson has found to be larger. This star is part of the open cluster Stephenson 2. It is about 18,900 light-years from Earth and quickly set several records. First, as you may know, Stephenson 218 is apparently the largest star known to mankind. If you put this star in the position of the Sun, even Saturn's orbit would fit inside the star. Even the 5 planets closer to the Sun than Saturn, such as Earth, would be swallowed up by this giant star. Stephenson 218 is also one of the brightest stars in the Milky Way galaxy. One theory claims that its brightness is 440,000 times that of the Sun. Certainly, some calculations show a more conservative figure of only 98,000 times brighter than the Sun, but even so, it can be said to be an extraordinary brightness. If our Sun were shining as bright as this star, not only would it be impossible to see, but the Earth would be completely burnt to a crisp. Because it is so unusually bright, Stephenson 218 should be clearly visible from outside our galaxy. If there were a well-developed civilization somewhere in the Andromeda galaxy, Stephenson 218, our hero this time, might be one of the first stars in the Milky Way galaxy to be discovered by aliens from that civilization using a telescope. Now, Stephenson 218 is also a star with an extraordinarily low temperature for its class. The photosphere temperature does not even reach 3,200 Kelvin. This star is classified as a red supergiant, but in general, stars of this type are a bit hotter, at least 3,500 Kelvin. To begin with, Stephenson 218 is a very rare star overall. It is classified as an M6 type in spectral type, but it is not a very common class of red supergiant stars. Also, Stephenson 218 is too bright for this class, and conversely, its temperature is too low. Of course, we cannot rule out the possibility that scientists made a mistake in their calculations somewhere. But if the calculations are correct, this unusual star will cause a stir in the current scientific models, especially those concerning stellar evolution. What do giant stars illuminate? When we talk about various unusual stars, the general public asks one big question. That question is, can life exist in that star system? But so far, not a single planet has been found on today's heroine, so there is not much we can say about it. But just because a planet has not been found does not mean it does not exist. Then I would like to imagine what planets are possible and what are the prospects for this planet. First, we need to keep in mind that Stephenson 218 was not originally what it looks like today. Not a single star has been a red supergiant since birth. A star becomes a red supergiant after it ages. Incidentally, while not becoming so gigantic, our Sun will also have a similar fate. We have no way of knowing what kind of object Stephenson 218 was before it became a red supergiant. But presumably, it was quite a massive giant star, classified as a spectral type, similar to the Sun. And it was probably in such a state for billions of years. This is a long enough period of time for life to have developed on the planets of this system. At that time, Stephenson 218 was not very large, at most 2 to 3 times the size of the Sun. It was not a very bright star, but given its other characteristics, it was once quite bright and had a wide habitable zone. Maybe there was more than one planet that fell within the habitable zone. In other words, it is quite possible that life existed in the Stephenson 218 system, and there may have been more than one planet with such conditions. But what are the odds that we would find a way to travel interstellar, visit the site, and discover intelligent life? Unfortunately, the chances of that would be low. When Stephenson 218 began to expand and look like it does now, the planet within the habitable zone would have been swallowed up. Moreover, the luminosity of this star had begun to increase long before that time. This would have turned the surface of the planet into a sea of lava. That is, even if the planet itself still existed, any Earth-like life would have died out. But wait a minute, you astute viewers might say. As stars expand and brighten, shouldn't the habitable zone also expand? And if a planet close to its host star perished, shouldn't it have instead warmed up a previously distant object? Yes, everyone, that is correct. When Stephenson 218 was still young, the farthest reaches of this system were closed off to the infernal cold, like Pluto in our solar system. However, since the star became a supergiant, it has warmed up in temperature. It is quite possible that liquid water or atmosphere could have appeared there if there had been enough gravity. But there is one problem here. A star is only in the supergiant stage for a very short period of time by astronomical standards. A few million years or even tens of millions of years might be enough for life to emerge, but these would not be enough for evolution to take place. Moreover, if there were a planet in a distant area with a deep ocean under an icy crust, like Europa, and life existed there, global warming would kill it. The ice crust would melt, and the oceans would be vulnerable to cosmic hazards, such as increased radiation from the stars. In short, even if there had been intelligent life in the Stephenson 218 system, it would have died out a long time ago. At best, intelligent life would have moved to some other system with a longer lifespan. Fate of giant stars. As I mentioned earlier, a star is only in the red supergiant stage for a very short period of time. As a star expands, its gravity cannot sustain an atmosphere in its outermost layers. As the atmosphere dissipates into space and the mass of the star decreases, so does its gravity. As a result, even more material becomes unsustainable. There is nothing to stop the star from melting. In the end, only the nucleus remains, and the star turns into a white dwarf. This concludes today's video. Thank you all for watching. I hope you like this video. To summarize what I have said so far, we are living in just the right time to be able to observe rare stars like Stephenson 218. Maybe we should be grateful to the universe for that. Studying this star will give us a lot of information about the fate of other stars, including our own sun. It is a pity that we cannot send a probe to this star with today's technology. It is true that we will not be able to see intelligent life in this star system. But the universe is full of other interesting things besides aliens. Please, subscribe to our channel so you don't miss any single interesting topic. Don't forget to like and share this video with your friends on social networking sites. And of course, we welcome your comments on our videos. Your cooperation is the very source of our channel's growth and evolution. That's goodbye for now. See you soon, everyone. Bye.